Every day, we use different devices for transporting us from one place to another, for generating energy from different resources, and for making our lives more comfortable, we use a multitude of convenience appliances. But have you ever asked yourself how they really work and what they all have in common? Let's see. An elevator has an electric motor which creates a rotational movement. Using sheaves, some ropes, and a counterweight, a linear movement is created, and this is how the elevator goes up and down. In a modern ship, the propeller is also moved by an electric motor, which generates a linear movement of different speeds, producing different degrees of effort or force. In the same way, the linear advance of the electric vehicle is created by the rotational movement of the wheels. In general, there are two tractive wheels and two non-tractive wheels. The tractive wheels are moved by an electric motor thanks to a special mechanical transmission. Trains, metros, and locomotives are based on the same moving principle as electric vehicles. In one or more train cars, there is a traction bogie. But how can the motor ensure the desired speed in these four devices? How is it possible to obtain a controlled longitudinal movement without being affected by unpredictable factors, such as different loads, different sea conditions, different road conditions, headwind and tailwind, etc.? Let's see. The electric motor is responsible for providing the appropriate rotational speed and torque in each specific moment. However, the motor by itself is not able to provide the adjustable torque, effort, or speed. It needs a power energy source and a power electronic converter that takes the necessary energy from the energy source and provides it to the electric motor. Lastly, a control algorithm is required to control all the components. The ensemble of these three elements, power electronic converter, electric motor, and control, is known as electric drive. Using this technology, the following is possible. The elevator movement is always smooth and comfortable, and it stops at just the right level. In the train, we can obtain a constant speed independent of the load it is carrying. The ship is able to keep a linear direction. And in the electric vehicle, slipping, for instance, is avoided. That is why the different elements of the electric drive must be carefully designed, depending on the specific requirements of each application. To learn more about the technology presented in these four applications, you can find more information in this book.